In the previous lecture, we had discussed about the principle of the slope detector, and this was the uh, slide wherein we have discussed about the principle of the slope detector. The limitations of the slope detector is it is having only one tuned circuit, which is inductor and capacitor, only one pair, and because of that, it is only going to tune to a one carrier frequency. Another drawback of the slope detector is that it is having uh, very limited linear range, and because of that, uh, these two drawback we are going for the next circuit, which is called as balanced slope detector. Again, the drawback is since it has only one inductor and capacitor pair, it can only tune to one frequency. It cannot be tuned to other frequencies than the carrier frequency. And another aim for the next circuit is we have to increase the linear range so that our more frequency components can be captured. The second type of the demodulator which we will be able to study is the balanced slope detector, followed by that Foster-Seeley discriminator and the ratio detector. Now here you can see this is the circuit diagram for the balanced slope detector. So in the balanced slope detector, instead of having only one inductor and capacitor, we will be having two inductor and capacitor pair. In the other words, the balanced slope detector circuit is constructed by connecting two single slope detector. So you can see in this particular diagram and in the next diagram, I will be highlighting that this LACA D1 C1 R1, this is our one single slope detector. If you remember in the previous lecture, this LB CB C2 D2 R2 is going to make another balanced slope detector. Now, two disadvantages of the single slope detector, if you remember that we require more pair of inductor and capacitor because we have to tune our circuit for more frequency ranges. So here we have two single slope detector connected in back-to-back fashion, and back-to-back means you will be having a output taken from the ground is connecting here. So whatever voltage will be developed here, that voltage if I am marking as VO1, whatever voltage developed across this diode is VO2, then output voltage will be VO1 minus VO2. Here it is written as V1 and V2. So output voltage is differential output voltage, which is V1 minus V2. Because this particular center tapping is connected, it is connected to ground. So in this diagram, you will be able to see that two boxes are marked here. This is slope detector 1, which is tuned to different frequency, which is Fc plus delta F. And this is slope detector 2, which is tuned to another frequency, which is Fc minus delta F. So this inductor and capacitor will be tuned to Fc plus delta F, detected by D1 R1 C1. This particular inductor and capacitor will be tuned to Fc minus delta F, and further it will be detected by D2, R2 and C2. The output voltage VO will be equal to V1 minus V2. The input signal to this particular circuit will be definitely our FM input, and balanced slope detector is the combination of two single slope detector. Now, let us understand the working of this particular circuit. So there are two circuits shown in this diagram. Whichever is comfortable can be drawn in the exam. So balanced slope detector means combination of two single slope detector, and output will be equal to V1 minus V2. Now, this is the transfer characteristics of the balanced slope detector. So you can see clearly the three frequency components are marked on the x-axis. One is the carrier frequency Fc. Second frequency is Fc plus delta F, and third frequency is Fc minus delta F. Now, why we are talking about two frequencies here? Because in the diagram, we have used two pair of balanced slope, single slope detector, one tuned to Fc plus delta F, another tuned to Fc minus delta F. And because of that, you can see the useful range or the linear range, which we have talked in the previous lecture, is increased. And this is what was the first drawback of single slope detector, that it has very limited linear range, and that is increased here. The second drawback of the single slope detector, that it has only one inductor and capacitor pair, and that is why it can be tuned only to one frequency, and that drawback also is eliminated in the balanced slope detector by having two pair of inductor and capacitor, which will be tuned to Fc plus delta F and another tuned to Fc minus delta F. And because of that, you will have more linear conversion from frequency to amplitude. Now let us understand the working of this particular circuit with the help of these transfer characteristics. What is the input to balanced slope detector? The input to balanced slope detector is our FM input. What are the frequencies in FM? It consists of a carrier frequency. It consists of higher frequency Fc plus delta F and lower frequency Fc minus delta F. So we will consider case 1. So for the case 1, assume that for the case 1, the FM input signal consists of the original carrier frequency Fc. So it will be, what will happen? If your input frequency F is equal to Fc, then input to diode D1 and D2 is equal, because inputs are given to us through a center tapping, and because of that input to diode D1 and D2 is equal, and because of that voltage developed across the output V1 and V2 is also equal, and that is why what is output voltage? V1 minus V2, and therefore it will be equal to 0. And that is why you can see here, when input frequency F is equal to Fc, input to diode D1 and D2 is equal, therefore VO1 is equal to VO2 and output is equal to 0. That is, you are at this particular point. Now consider case 2. For the case 2, what will happen? The frequency is increasing. How frequency will increase? Because deviation is positive. So Fc will be now changing from Fc to Fc plus delta F. And then what will happen? When your frequency is more than Fc plus greater than carrier frequency, then input to diode D1 is higher than diode D2. Therefore, output voltage VO1 is greater than VO2, and therefore what will be the difference? VO1 minus VO2 will be equal to positive, and that is why when the input frequency is increasing, this particular curve you will be getting. Case 3. In the case 3, what will happen? When the input frequency is less than the carrier frequency, means it is Fc minus delta F, it should be here Fc minus delta F, then the input to diode D1 is less than diode D2, and that is why VO1 will be less than VO2. The difference is VO1 less than VO2 means VO1 minus VO2 will be negative, and therefore output voltage will also be negative. So this is how we are getting this particular curve, which is also called as transfer curve. Some books are writing it as S curve because the shape is of like S. Then the advantage which we are getting here is that we are having more linear region, more linear range we have here. And because of the two pair of inductor and capacitor, it can be tuned to two different frequencies, Fc plus delta F, Fc minus delta F. Upper section will work for Fc plus delta F, output will be positive. Lower section will work for Fc minus delta F, output is negative. And when you receive only carrier frequency, output will be equal to 0 because we are taking differential output. Now in the next lecture, we will be able to study about the second type of slope detector, which is called as Foster-Seeley discriminator.